So without further ado, I'd like to bring up the next speaker, who is Professor Barbara Lane. In the program, you also have bios for all of the speakers, so I won't go through and read the bio. I'm hoping that Barbara will explain to us, however, the meaning of the man in the blue Adidas shorts, the blue silk Adidas shorts, perhaps. But in any case, Barbara, in addition to being a visiting professor at the University of Edinburgh, is also Global Fire Skills Leader for Arup, and probably requires no further introduction. So whenever you're ready, Barbara.
Good morning, everybody. It's a very personal honour for me to be speaking at Edinburgh University today. And I was asked to reflect on then, now, and what's next. And when it's referencing a place that holds such strong and fond memories for me, you can't help getting a bit sentimental. But the good news is I'll overshare all of that at dinner this evening rather than during my talk today. I do want to talk a little bit, though, about the past. My time here was midway through the 40 years, and before Jose Torrero was even a twinkle in the eye of the department, and I'm going to come back to that in a second. And the Cardington fire tests hadn't even started, as Luke reminded me yesterday. Dougal brought me on a trip actually to see one of the Cardington tests, and I met all the boys, as I like to refer to them, who thought it was nothing but hilarious that Dougal was now travelling with a young 22-year-old blonde girl, and didn't at all associate me with the fact I was his PhD student. So that gives you an idea of the atmosphere I was working in. It was also a time, and I really hate to have to admit this in front of all the very young people in Arup Fire who are here today, where PhD students were only just starting to use computers during their PhDs, and that's a horrendous thought. And Pete Thompson, who's going to be speaking afterwards, I can still actually remember the day when he brought me to my desk and there was a PC on the top, and I asked him what I was meant to do with that. He was absolutely horrified. I'd left Trinity. I think there were about 10 machines in the computing lab, and only very kind of weird people used them, not the rest of us. But by the time I left Edinburgh, Google was 1 year away from being invented, and people didn't take photos on their nights out to upload onto social media, and I am very, very, very glad about that now. Dougal sat in a room piled with books and all the very late papers for the Fire Safety Journal he hadn't got around to reading yet, because I used to do that for him, and a line of PhD students trying to see him. And he very much left myself and all the other people who were doing experimental PhDs at the time to deal with striking lab technicians, and I won't go on anymore, Dougal. But the point I'm really trying to make here is I relish greatly, and that is in a bit of an evil voice actually, how well this fire department has gone on and how well it survived, despite, quite frankly, the best efforts of the university and the engineering school at the time to get rid of fire. I gave a very long speech about this at Dougal's retirement do, so we won't go there again. But now it's a place that produces a whole generations of highly skilled evangelical believers in the excellence of fire safety engineering, and I absolutely love that that's where it's come to. Like anyone who studied here, I have to admit that I would be nothing without the 5 years I had at Edinburgh professionally, and so I'm also very grateful. So we'll leave it at that. Okay. Let me just 1 second. Yeah. Okay, so the actual presentation. So I'm reflecting on fire safety design and practice. And it is written from a purely Arab perspective before anyone gets upset, and it's probably also terribly UK centred. That's for the purposes of simplicity only. I was running at about 15 hours yesterday when I was trying to get this thing down to the 20 minutes. But because I'm Irish, you'll know that I do not believe the UK is the centre of the universe by any stretch of the imagination. Okay. So first, I do need to declare the special relationship between Arup and Edinburgh University. It was born in the Rasbash and Margaret Law times, and we have always exchanged ideas, advice, and solved problems for each other. it was traditionally on a voluntary basis, based on kind of human relationships. However, once I started at Arup, we made the first steps towards more formal funding of PhDs bit by bit. And it's when I tackled Sir Duncan Michael, who'll be speaking to you later, about maybe doing something more. It's also then, it has to be acknowledged today, once the torch paper of Jose Torero at Edinburgh was lit, there was no turning back. And through Jose, Luke, and our new recruit, the sociologist Graham Spinardi, all sorts of exciting new futures are possible. And I absolutely love this graph that Luke didn't realise why he was giving it to me, which is of the student numbers at Edinburgh and how they've changed since Dougal passed the mantle to Jose Torero. And I think it's very important that we acknowledge that today. It's a great graph. Okay, so what does 40 years, how do 40 years look from this perspective? I've looked at the 4 decades, which resulted in some very long-suffering Arup Fire employees sending me spreadsheets with 4,000 projects on it yesterday and trying to sift through all the detail to understand any kind of trend I could find. First, I'll go through the 70s. Rasbash was here, and in 1974, Margaret Law started actually at Arup the same year. She joined us because she wanted to now apply her fire science knowledge and experience on real construction projects. The Pompidou Centre was one of her first fire engineering projects at Arup, and it's always lovely to go into our archives and read, the handwritten notes and the letters exchanged. Brilliant education still. It was designed by, at the time, unknown architects, Renzo Piano and Richard Rogers. They won the competition, which was highly unusual to win a competition in France, if you were an outsider then. And they were told to transform the heart of Paris and make it accessible by all. It was created with steel and glass rather than the typical concrete for the time, and all the building services are on the outside of the building so that the floors are fully free for maximum flexibility. It was originally designed for 8,000 people a day and absolutely hated by Parisians. It's now visited by 16,000 people a day, and I'd imagine secretly it's far higher, but they can't put that on their website because they're probably breaking all the original fire strategy principles. In requiring all aspects of the space to be entirely free for the building user, which a fire engineer at that time would not have been involved in, Margaret Law's role was to enable the complex external steel structure only. And this was achieved through the creation of water-filled the main external columns are water-filled. They've pumps for circulation. They're triggered on fire. I'm not sure how. And then a series of fire-resisting shielding panels in the facade system to protect significant brackets only. Each floor was divided into 2 compartments, purely for the purposes of limiting the number of elements of structure that might impact stability in a fire. And I wonder how well that went down, actually, with the architect. The design work at that time in the 70s was very much focused on post-fire investigation and these very specific issues on external steelwork. And I should have, I have another few photos there. It was also a time, actually, in the 70s of some significant fires. I've shown the Woolworths fire in Manchester here. I think people probably know, I think history tells us people stayed eating their lunch. There was all sorts of very unusual things happened in that building. And you may not know it now, it went on to form the basis of some of the standards we follow today. So that's a quick rattle through the 70s. The 80s then, Arup Fire was still just in London, but our international work was starting to pick up. The building regs were invented and the approved document B had its first glorious publication. And kind of signature projects for us at the time through Margaret were, say, the large open-scale compartment that is Stansted Airport. It was also the beginning of the fashion for atria, which, as lots of you probably know, in the minds of many, is the only reason fire engineers exist in the first place. But work was also starting to, take place in other countries such as Hong Kong. But it was still a decade of, very, what I call niche area, bespoke fire safety engineering. Again, there was some very significant fires that occurred, the Stardust Disco in Dublin, which impacted licensing laws, the Bradford City football ground, and we're all still using the safety at sports ground, the work from there, and also the dreadful King's Cross underground fire. And again, that triggered some very groundbreaking research here at Edinburgh and other places, and still underpins the recommendations and legislation we rely on today. Now, the 90s kind of really is where we see the first big change. And, I suppose you can apply any kind of trend to anything, but for me anyway, I think one of the big things that changed for us then was the introduction of design and build, where the contractor took a very conceptual design, designed it in inverted commas himself, and then built it. And actually that really changed, design and construction in the UK anyway. But it meant, though, that for a lot of contractors, they started to see fire engineers as people who could drop down costs on their project and help them win the project. And when you hear people ranting on about fire engineers only exist to kind of, save money, that actually stems from those times. But it was also the decade when the starchitect really came into the fore. And each individual architect, had an associated desirability when it came to creating a successful project. So for clients looking for a unique building for them, a particular starchitect was selected, and they could enable and ennoble his vision. If you think about something like the Tate Modern or any kind of glamorous building around the world. But also, in a theme I'm trying to touch on today, the increasing urbanisation of our society was well underway by the 90s, and that's kind of gone on to impact us greatly. But it was the scale of the projects and the increasing demand for unique buildings, and for value engineering that really drove the growth of fire engineering practice then. And we opened offices in Hong Kong, Melbourne, New York, Dublin, Sydney, Leeds. You can see it when you go back. There was a massive growth of fire engineering demand. It was also the year when we did our very first ever fire engineering project in China. And I was very interested to hear from our fire team there yesterday that this is the first year ever in China you can become a chartered fire engineer. So again, it's interesting to see, the changes over the decades. But it wasn't all so great either. It was a decade where, in many countries we were just coming out of austerity. And so it was a time where lots of governments started investing in significant infrastructure projects. And so project scale was really now starting to change. I've put the Channel Tunnel up there. It was the most expensive construction project ever proposed at the time. It was worth in the end £9 billion. I'm sure at the beginning no one imagined it would cost that. But just to give you the scale of what people were trying to achieve. And there was all sorts of different reasons why infrastructure work became so significant and continues to be so significant for fire engineers. I mean, these projects are aimed to improve city connections, to deal with overcapacity and the problems of our increasingly populated city environments, and also part of a philosophy to regenerate areas that were literally on its knees after very harsh times in the 70s and 80s, something that can be recognised in different times all around the world. The thing about these projects, though, for a fire engineer is they're above and below ground, and they have all sorts of different types of complexity, and they're not covered by any of the standard prescriptive guidance. So again, this demand and need for fire engineering skill grew, and also it meant we had to start thinking about things beyond life safety. But I'll leave it for that now. Okay. The interesting thing about infrastructure work, actually there has been plenty of lessons learnt, and actually the lessons carry on being learnt through the decades if you look at the list of fires. And there's been some substantial research work there that people in practice rely on today. The buzzword then of sustainability, is a driver too, because if you can get people off the roads and onto trains, maybe you're more sustainable. I'm not going to comment on, whether that's true or not. For example, in London, there's been an 8% increase in population since 2000. a 5% increase in the number of jobs available, and that's going up and up and up every year. That's why I've shown, say, the new King's Cross station and the new massive Crossrail line they're building. All of that is to deal with the urbanisation of our society. Something we're also seeing then is people building cities in the middle of a desert, which surely isn't sustainable. And we get requests to carry out fire engineering in 3 months on a 29 station, 60 kilometre length of tunnel, maybe by 5 people all at once. And I'm saying that to try and show the scale of what's happening out there now in the context of infrastructure investment and what people are trying to do. Okay, so in the noughties, the concept of tall building had totally altered. And the role of the growing megacities and the move towards this substantial urbanisation I'm going on about was by now impacting planning laws, infrastructure needs. There was less and less space in the older cities, and so the move towards and creating entirely new cities in the desert, in the Middle East, for example. And I won't talk about all the people removed from Beijing to build tall buildings by Arup, because that would be very naughty. Okay, I'm going to just zoom through here. If you look here at the evolution of tall buildings in terms of their scale and form, just from the 30s, that was Arup's first high-rise building. Arup designed that himself, say to something like the Shard or any one of the structures there. You can see how shape and form have changed over the decades, and so there has been new requirements for the fire engineer over the decades. And this is London today. There are currently 236 tower buildings planned or under construction in London right now. That's an absolutely phenomenal number of buildings, and I hope it's kind of illustrating these points I'm trying to make about the challenges coming up in the future. The noughties were also a time of the World Trade Center. I won't mention that now, but that changed a bit. Edinburgh, many people carried out highly forensic assessments of structural fire engineering then, and it revolutionised our understanding of structural performance and fire performance. But it also created a scale of data that we've never had to store or to understand or to communicate before, and that's another theme of this talk. And through all this complexity, you might say, it means that in this decade, we can no longer simply work on the design environment and hope that everybody else leaves us alone. We have to be part of, as fire engineers, we have to be part of the construction team, going through the myriad of details that actually makes up building a fire strategy, and the myriad of detailing needed to operate a truly resilient building. So we have to now be involved in the whole cycle of the thinking through to the operation of a building in all its form. So the advances in technology, maybe they've caused us some new problems to solve just by existing, but it's also given us an ability to solve problems that once we couldn't. Okay, so the significant drivers I've tried to summarise here, the 40 years seem to have been driven by the information age and the digital revolution, how we live, where we're living, and the use of new materials as, say, energy regulation and code requirements came in because of concerns about global warming. And also, actually, I really horribly realised that a lot of this is driven by increasing affluence and the desire for wealth, because a lot of this is driven by, finance and the financial markets. Okay, so where are we going? The last piece of the slide. So I actually don't like talking about where we're going, because frankly I don't really know, okay, and I don't really think anybody knows, but anyway, that's the subject of another talk. But I am going to talk about some things that are starting to become a problem for us at work, and so it must mean that maybe they're the problems, that's the future, the new future is starting to appear in front of us. Okay, so the first thing I want to talk about is the considerable challenges we're having now in designing building envelopes for the future. And before everyone gets a little bit bored, you need to talk to Charlotte about how complicated this is exactly. It's really about the true integration of fire safety design solutions in designing building envelopes. Now, I asked for the weirdest, most complex facade we've ever designed, so I hope you've worked out that's that there. And apparently those little umbrella things open and close as a function of where the sun is. But the truth is, life is actually typically more like over, on the left, and that's really where I'm speaking about. I mean, in the old days, a facade or a building envelope was just to keep the rain and the wind out, and it leaked all the time, and the truth is nobody really minded. But as you go through all the decades, as energy requirements increased, as people wanted more, from their building envelope. I know we don't really know we want anything, but as it became less acceptable to have such poor performance, architects and engineers have had to change how they design those systems. And it's caused them to start creating very lightweight systems with all sorts of new types of materials. Remember, the starchitects had a role here, and the architects, because they wanted, maximum light, maximum visual appearance, but still had to comply with the rain, the wind, and not letting the heat out. And actually, there's been some incredible innovations in that field, outside fire engineering. But it does mean now that we have very efficient double and triple glazing systems and highly insulated building envelope systems, and sadly they all tend to be built with highly combustible materials. And at the moment we're trying to explain to people why that isn't okay, but we're not actually able to help them design something that can work. And by work we mean it meets the non-fire drivers for the building, because it's very significant that people be allowed to do that. And so that there's something massive in there that needs to be worked on. The other issue then is this age of affluence has created formally a massively ageing population. That doesn't mean we're all kind of getting old. It means there's more of us getting old than there are young people to look after us. And this is a very significant driver now in the future of design, the future of where practice needs to go. All this increasing wealth, has given us all sorts of healthcare, all sorts of things that is allowing people to live longer. And it's unprecedented in human history, so we can't ignore this change. Different countries are at different stages in the process. If you think about Japan, where they're already having a problem, whereas somewhere like Australia, their proportions are almost, their proportions are still okay. But all facets of human life are impacted by this change. If you think about working, housing, transport, leisure, health, everything is impacted by our population. And so again, I think there's something really substantial coming up in the built environment there that fire engineers need to get ready for. Arup are already being asked to design assisted living accommodation. There aren't any codes and standards to help us, and there's very, very little research that we can rely on. So again, hopefully something people can work on there. I think I'll come into an end. Yeah. I was going to just briefly mention this concept of data and information. Let me just get my notes. Yeah, this is geographical information systems. Apparently it's really easy to understand. But in essence it means creating a spatial database of information you have, not for a building, but say for a city or a campus, much larger geographical scale. For example, we're working with the campus in UCL at the moment. I'll show that to you later. It's on a much larger scale than a building. And it's to help people to find all that information at that scale, so they can work through the data appropriately. It isn't BIM, okay, before you think, because BIM is at the building scale, GIS is at the much larger scale, and I'll try and explain this better over lunch because Luke is really glaring at me now. What is BIM? Well, it's a descriptive term for a digitally enhanced collaborative design process. Those of you who are in consulting hear this term all the time, but don't be fooled. There's a lot of talk about it, but we aren't really using it properly yet. But there seems to be something of considerable value there for the fire engineering profession. In essence, it's a database with a 3D graphical interface, and there must be something there for the buildings of the future, how they're designed, and more interestingly, how the operator can go into the innards of their building and truly understand what the fire safety design requires. I don't know, but somebody needs to work it out very quickly, I would suggest. And let me know immediately then. Okay, I'm going to end on the BIM. So all of these things, though, bring me into my last point, okay, which is who's going to do all of this when thinking about the future. And that's probably the most significant thing to raise here today when thinking about Edinburgh. Because I hope I've shown through all the slides over the decades and what we're grappling with now, this total fire safety concept where the fire safety engineering knowledge is required, the whole circle of a building's lifetime. It's just simply not going away. And so my last proposal about the future is, the fire engineers, who's creating the fire engineers for the total fire safety concept? Because from where I'm standing, I can see nothing but an increasing fundamental need for fire engineers in the design stage, the construction stage, the operational stage, if we want to build truly resilient buildings designed for these very complex futures I hope I've outlined. And I can only see an increasing reliance for these resilient buildings on the skill of fire safety scientists and fire safety engineers. But more importantly of all are people who can integrate this highly specialised knowledge and then apply it in the real world. It will require codes and standards to keep up with this change of pace. It requires lots of education and maybe mass production of fire engineers. Who knows, okay? But it certainly is looking very good from here. Thank you.